Yes. So welcome, everyone. It's good to have you. Today we're going to talk about line triangles and triangles in our penultimate session for today. So just have one more session in which we'll cover two topics and we'll be good to go. So I hope the first 15 minutes were refreshing enough for you to get some exercises done. We'll try to jump to some more complicated, perhaps more interesting constructions. So try to take a moment to think about this and think about how we can tackle it. Maybe more than a minute. Maybe you can take 60 moments, so 60 seconds. For an exercise like this, the first thing I would recommend is to identify what we would like to find. Just try to identify the objective of the exercise, and then perhaps I'll take a look at the givens that I have, and then see where this leads me. So the minute going to be passed. The first thing I'll do is I'll identify what I would like to find. That is the angle TUR. Now let's agree on something. We're looking to find the angle TUR, so we go in this order, TUR, and we take the angle that's in the middle. If you've never seen this before, I presume you already have, but perhaps it's a good reminder. And by this logic, TUR would be the same angle as RUT, for example. But that's not important for now. So this is the angle we're looking to find. And let's see what we have. We have a measure of the angle VTU, 162 degrees. We have SWU, 85 degrees, SWU, SXQ is 86. SXQ. And finally, I think SQX is 48. SQX is 48. So I've identified the goal from the exercise. I've written down the givens. This is a lot if you're trying to solve a problem like this. Just writing down the givens and identifying your goal is a big step forward. Now let's agree on some basics. The first basic thing I want to agree with you on is that the sum of the angles in a triangle is always equal to 180 degrees. You can take this as some sort of axiom or fact. If you want a proof, maybe we can talk about it, but I don't think that's interesting. And this is actually the first fact that we use here. So I don't know if you see this, but this is a triangle. And we know two angles, just don't know the third. So we can actually write in the triangle QXS. Here's what's happening. First angle plus the second angle plus, let's say, a third angle, which is XSQ, be equal to 180 degrees, because that's the sum of all angles in the triangle. The fact that I just mentioned here. But in this case, you just move the other variables to the other side. I think the answer is going to be 46 degrees. Let's also check. So we move the equations, and then 180 minus 48 minus 86. Yes, it is 46. That's good. I have one more piece of info. Still, I'm not there yet. Okay, well, that's fine. Because if you know the second fact, so I hope this is pretty obvious, but I'll just state it. We know that if we go into a full rotation, it's 360 degrees. And if you go half a rotation, just half of this, it's 180 degrees. And so this is precisely what we mean here. If there is a line, a process, let's say some straight line like this, then it divides it into two angles. Sum of the two angles is 180 degrees. This angle is some x and this angle is some y. Then I can confidently say that the angle x plus the angle y is equal to 180 degrees, because it is half a full rotation. And if I actually just remove these two, which I'll do just for a brief moment. So this angle is 180 degrees. The angle is not obvious because it's just a straight line. But in this case, you would say, okay, the angle is 180 degrees. But this is not crucial for our understanding of the problem. So this is the second fact which I'll use. I'll actually use right now. Because here's the thing. This is a straight line. And if this is a straight line and this is 46 degrees, then this angle should supplement it to get 180 degrees. So this angle should be 180 minus 46 degrees. So 134. Let's see where this takes us. Not quite sure, but here's what I'll say. Let's apply the same concept again. So 162. There's a supplementary angle here. So once 180 minus 162. Apply the same trick, you get 18. Okay. So this seems to be promising, because just need one more fact to conclude the exercise.
We could look at this also from y, which is point W. So we can also we can say 0.80 minus 95 gonna be 85. I mean, gonna be 95. 95 plus 64 is a number. We're gonna also take it out from 180, which is gonna the angle SRW is gonna be 36.
So we have this is a strong claim. You're saying SRW will be 36. But why?
Um,
You could, yes, you could,
just since that also
if you would
Yeah.
like.
the sum of this angle with the other
You
side is 100.
use the white one.
This angle, how could I?
So
Yeah,
you
this
need to
angle.
use you need to use the pen. Yeah.
Yeah, this angle is gonna be 95. This one is gonna be 95.
Okay, tell us why.
Yeah, since these are 180. These two, so half circular.
Ah, I see. This is very good.
And
You
this,
see this?
we sum it with this, it's gonna give us.
So and then this is the second fact, right?
Yeah.
So this is the second fact. This is 95, this is 46. So this
And we're gonna get the
36. Okay.
And from this value and this value, we're gonna get this one, and we could do something else, which is this. This is outer angle, which is equal for this value and this this angle and this angle. This one equals sum of this and sum of this angle. So 36 plus this x equal 162.
And then you just say no.
Yeah.
Yeah. Okay.
We
That's
could
interesting.
say this plus this, we take it from 180. We're gonna get this solution.
Okay, I'm very happy with this because I was looking for the solution you gave us too. So thank you very much. This is a very clever way. Let's focus on your first one. I'll just remove this and I'll go back here. Thank you very much. Then we. Yes. So this is very clever. I like that you've applied this second line property to this position. I think it's very, very clever. I didn't even notice it. So that's very good. So if this is 95, and this is 85, and this whole thing is 180, then as Ali said, this will be 95 degrees. And then this is a triangle. And we know the two angles are 95 and 46, so this should probably be 36 degrees. And now finally, to conclude the problem, we focus on the big triangle, which is the red one. This is not precisely highlighted, but I hope you can see it well enough. And in this triangle, we have the first angle is 36, the second angle is 18, and the third angle is the green one. So we can write down the following. So 18 degrees plus 36 degrees plus the green angle is equal to 180 degrees. And from there,
There's an issue. So that I 36 with 49, 46 is
okay, let's see. So it's 46 plus 95,
that's
95 plus.
I think it's gonna be 30.
No. So maybe it's 39.
Yeah.
So this is probably 39 degrees. Okay, that's fine. So the computation is not important that much. I think the more important thing is the idea. So this is true. Then our green angle should be equal to 180 minus 39 minus 18, which is 123. So the answer is as simple as 1, 2, 3, right? Yeah, so that is the answer. It's a good problem, I think. It's a good starting point. So I think when we do the other exercises, I don't think they'll be as difficult because the themes are very much recurrent, you could say. Let me switch back here. So I hope you can see this problem well enough. Or is it too small? Should I zoom in? It's good. Okay. So you can think about this for a couple moments and see the answer should be. And by the way, if you have a solution, you can let us know.
97 degrees.
97 degrees, that's amazing. You like to do it?
Sure.
You know how to activate the update. Let's try to do.
So find this angle here
Okay.
is maybe erase again. There you go. Is say whatever. Y is 180
Okay.
minus 106 y, which is 74.
Yeah, so you're using the fact that this is a line and there's a line that intersects it.
Yeah.
So you take away 106 from 180, you get 104. Great.
So then to find this angle here, which we'll just say is C, then it's 180. To find the inner triangle, it's 180 minus 23. So 180 minus 23 minus 74, which equals I don't know,
Let me see.
97, I think.
27,
23.
27, 7,
80.
27. I think it's 83.
Yeah,
I could be wrong.
24 is 80.
83.
So this angle here is 80.
Yeah, so that just has to be. You can just, I don't know, just draw a line.
Okay. This is 83 degrees, and then to find x is 180 minus 83.
Yes.
Is x.
Yes. What was it? It was 90.
I should be able to do that in my head, but
Careful, you're on the big screen.
97.
Yeah, 97. Okay, that's good. So you've utilized both ideas that we.
You know what? بس كده أروح wrong.
Why did you get the
I
wrong result?
view that as a post parallel.
That's what that was. It was parallel.
Yeah.
What was parallel?
Yeah, but they are not parallel. Like if they were parallel, that the x is gonna be 106, not gonna be. Like the two angles are 180 if they were parallel. Inside angles.
Uh-huh.
They had 180.
Uh-huh.
So I deal as they were only 180 but two angles.
Uh-huh.
But I told you because they are not parallel, so I can't apply this action.
I see what you mean. Yeah, this can be a bit problematic. That's why you can't really trust the drawings. So they do draw the drawings to scale in the exam, but even if they do, you shouldn't try to trust them. Just try to use the data that you know for sure, and from there make your inferences. So this is 100% correct. Thank you very much for this. The answer is 97 degrees. Right, yes, so the answer is 97 degrees. Let's take a look at perhaps some more interesting. Okay. Perhaps some more interesting exercises. Let me take a moment to assess this. This is interesting. I'm on. It looks interesting to me. What do you guys think? Yeah, let's do it. Yeah, doesn't look too bad.
Stealing the United. The sides are equal for the triangle.
Well, let's see. Let's see. So take a moment to think about this.
Might play around with the camera. Hmm.
So we're looking to find Q and R. And what are the givens? NP is equal to QP. And MP is equal to PR. That's good. Yes, it is a very interesting problem. I think it deals with a different idea, which I think is it's about congruent triangles. Have you heard of this theme before?
You know, if the both sides are equal, then both angles, which is lines with that, is also equal. Like it's a bigger angle.
So you mean if you have something called, so let's say something called an isosceles triangle, where let's say this is angle star and this is angle star. If sides are equal, then the angles are equal. This is why you want to say.
That's why also if the third side were also equal to them, then it's gonna be exactly the same degrees for each angle.
So you mean that if you have even more special case of a triangle, I'm just trying to make sure I understand what you're saying. If you have
also like this,
then all three are equal.
yeah, it must be all three angles.
Yeah, this is the equilateral. This is the equilateral triangle. All the angles are equal to each other, and sum of the angles is 180. Then what is each angle going to be?
60.
60 degrees, right? 60 times 3 is 180. But yes, it is a common theme. If you have two equal sides, then the angles are the same. I'll put this on the side. I don't think it is relevant for the problem, but this is much more relevant because here's what we have. So let me not fall into this trap. NP is equal to QP. These are different sides. These two are equal, and these two are equal. There's a slight difference. I think what's going on here is that we have a case of congruency. What does it mean for two triangles to be congruent? It means that they are exactly the same. So if let's just assume right now, that I say triangle ABC is congruent to some triangle, let's say DEF. Then what I'm saying is that the side AB is equal to side DE. You can read it off, from the segments. AB is equal to DE, BC is equal to EF, and AC EF. Also the angles. So the angle ABC is equal to the angle DEF. It's just go in the right order. You always get the correspondences. So this is very important. I'm just hand waving this because in the end, you might not even use it. I have a good idea to find this angle here. Do you see it? Yeah, not the angle, but the idea. You see the idea. Yeah, so we'll just apply what we've just done. This is a straight line, so this should be 120 degrees because the sum should be 180. This is another line, which means that this should be 60 degrees because the sum should be 180. And if I do the same thing again, this is 60 degrees and this is 120 because they have to add up to 180. So that's good. It's a triangle. I know one angle. If hypothetically I were to find this angle, then I would be done. But I don't know. Let's keep exploring things. We still haven't utilized the fact that this triangle, in this triangle and that triangle, we have lots of similarities. So we have two sides and one angle that are exactly the same. And can we say something on this triangle? Well, first off, this triangle, the first angle is 60 degrees, the second angle is 70 degrees, then probably this angle should be 50 degrees so that they sum up to 180. Okay, so that's more progress. Sure. What can we do? What can we do?
You can solve with 3 ways.
Yes, but I just need one. Do you see?
You can use it with the 50. Can get the difference between 50 minus 90. Then it will be 40. No, so we should have orthogonal.
We could have a good idea.
Hmm.
I don't think we'll use congruence in this problem. So that's why I didn't really go over it. But here's this. Let me tell you that we will use the fact that there is a certain triangle which will be isosceles. And if it's isosceles, it means that the two sides are equal. The two sides are equal, then the corresponding angles should be equal. Now, do you see the triangle that's isosceles? That is isosceles. Isosceles meaning this. So the angles equal to the angles. Which one is it?
This two.
So I just need one.
Yeah, the lower one, which is
The lower one.
yeah. So we're gonna divide the rest
So,
by 2.
so this is our isosceles triangle. If this is isosceles, then well, we know it's isosceles because two sides are equal. And if the two sides are equal, then the two angles are equal, which are corresponding. So the angles that are down below. So this angle is also the same. And this should be easy. It should be easy to conclude from this because this is a triangle. The sum of the angles is 180. 120 plus the green angle plus the green angle is equal to 180 degrees. Then it is clear that the green angle needs to be 30 degrees. It's then 150, 180 from the 120. And then we conclude. So it's good. We discovered some machinery, we didn't use it. It's totally fine. But I hope it is clear. Is it clear for you, Flavia? I know you're online and maybe you feel a bit disengaged, but I haven't forgot about you.
It's clear. It was.
It's very good. And if you also have solutions, you can, step up and do it. You can annotate, I think, on the board if you would like.
Okay.
If you would like to do, let's say, this exercise, just let me know. Hey, Omar, I want to do this exercise, and then we'll do it together. I think this is an interesting exercise. Because I think it's the first exercise doesn't talk about angles and talks about the lines and lengths of lines. But this is a very interesting problem. Deals with the topic of similarity. So two triangles which are similar are exactly the same triangles, but with different scalings. So for example, I'm not solving the problem, I'm just giving out, I don't know, hints. So this triangle is similar to this triangle. It's similar to this triangle, or this triangle, or that triangle, and so on and so forth. So when I say similar, I mean the angles are preserved, but the ratio between the sides, the scaling is different. So for example, if I take the same triangle and scale it by 2, so let's say I just multiply by 2, then this side, length of this side is half of this side, because I scaled it by 2. This is double that one, and this is double that one, and this is half of that one, and so on and so forth. So there's also always a scaling that's associated with that. I'm not sure if you've heard of this before, but I think you should have. You have ideas on how to solve the problem?
Actually, it's from the perspective of the rule, the triangle, which is half multiply the height, multiply the width,
The base.
the base. So we're gonna take the base as the Pythagoras triangle, which is 3, 4, 5, because we have.
So you're using the Pythagorean theorem.
Because we have orthogonal angle. If we hadn't orthogonal, we couldn't.
Yeah. So the Pythagorean theorem says that a squared plus b squared equals c squared. So if you have something like this. So a right angle triangle, basically. A right angle triangle, which I'm currently failing to draw. But so if you have a right angle triangle, then the hypotenuse is always equal to the sum of the squares of the other two sides. So you apply this. This is the first side. So the second side, then
famous triangles, which is 3, 4, 5.
yeah, it's a 3, 4, 5. It's a famous triangle.
So I use this in the law, which is half by 5 multiply the height. So I'm gonna take out the height and multiply half of 5, which is gonna give you the height, which is the n cube.
But I have a question.
Hmm.
What you say? You say that the rule, which is half times the
H
NQ,
times
right, times 5.
Hmm.
So half times the height times the base. What rule is it? What rule is this? What are you specifically talking about?
The height, which is here.
Yes, so this thing, what is this thing equal to? What does it represent?
This is the area.
It's the area, okay. It's the area of which triangle?
The bigger one.
The bigger triangle, so it's the area of M and P. But what else can we do? Do you know the area of the triangle?
Now. You know, meaning by numbers.
In a number, because if you have a number on the other side, let's say some number, then you say, okay, this is an equation in one variable, and I can find NQ. But do we have this?
That the area is unknown, so we can't take out height.
Yeah, the area is unknown, so it doesn't. We can't really make progress with that. Xavier, did you want to
I have an idea.
you have an idea? Would you like to, I don't know, annotate on the board?
I can say it and you write.
Okay, let me know. What do you want to say?
Okay, we can find angle P using the sine rule. Like that's sine P is equal to opposite of a hypotenuse, and that's yeah, and that's sine P is equal to 3/5.
3/5. So in the right angle triangle, you have these trigonometric ratios. I hope you've heard of them before. This is the opposite side, and this is the hypotenuse. The hypotenuse is always the side that's corresponding to the right angle. So this is 3/5, okay?
So P is equal to sine inverse of 3/5, which is equal to 36 degrees.
So if you use your calculator, you get that this is 36 degrees. You just need to
Yeah.
go here.
Then
Yes, well, something, right?
yeah.
Point is
And then to get n the length of NP, we say sine 36 is equal to, let me say it's x, like NQ is x. So sine 36 will be equal to x/4. Using the same rule of
I see what
sine.
you're doing. Yes, I see what you're doing. Just give me a moment. I'll just add a page and make sure to record what you're saying precisely. I think I got the gist of what you would like to accomplish here. Yes, so this is so you want to make use of the fact that we have two right angles here. We have one
Yeah.
right angle, which is n
Other Q and N.
yes, and another right angle triangle, which is
They don't put. No, I wanna use the one, the bigger one. Yeah. Okay. Yeah.
I'm just writing down the stuff kind of NQP. Then just want to make sure I put the this is correct. So I have two right angle triangles. This is the first one, and this is the second one. Hope this is good. You said the sine of the angle P in the bigger triangle, I think you said, right? In the bigger triangle, which is this one,
Yeah.
is equal to the opposite side divided by the hypotenuse. So NM divided by PM. Now PM is 5 and NM is 3. Now you want to make use of the fact that this angle is also in the other right angle triangle,
Yeah.
Okay, now go on. What do you want to say next?
And then we got 36. So we have 4 as the hypotenuse for the down triangle.
Yes, so this is the hypotenuse in this case. We would like to
Yeah.
find NQ, right?
Yes.
Okay. So if we take the sine of P in this case, what is the sine of P?
That's NQ over 4.
NQ over NP, which is the hypotenuse. And so
Yeah.
NP is 4,
Yeah.
and NQ is NQ. NQ is what we need to
Yeah.
find.
And
what
sine
is-
P is
Sine P
P is 36, so you say sine 36.
or you could just use sine of P, right?
Yeah.
So you don't
But,
actually
like I
need-
wanted values.
So what I mean to say is you don't really need to compute P or like P itself. You just know that sine of P is
Yeah. 3 over 5.
so 3 over 5 is equal to NQ divided by 4. Then in this case, NQ is equal to 4 times 3 over 5.
Yeah.
So I think that's 12 over 5. I think that's 2.2. I could be wrong. No, I think it's 2.4. Yeah, 2.4. This is a very
Point 4.
yeah, it's a very impressive way to solve the problem. Thank you very much, Flavio. Happy that we're able to participate. So this utilizes some knowledge about right angle triangles. Now, right angle triangles are something that we'll talk about next time. So I'm wondering if you would like to hear about similarities and in fact, these two triangles will actually be similar. So would you like to hear a little bit about that? Okay, that's good. So this is great. It's a great solution. Use trigonometric ratios. But let's say you don't know trigonometric ratios and you'd like to do this in a different way. So here's what I mean about similarities. I think we were able to roughly explain the idea of a similarity or two similar triangles. So two triangles which are similar are basically more or less scalings of each other. So it's like this is the smaller triangle and this is the bigger triangle. Well, why are they similar? Why am I saying? I'm just telling you this. Why should you believe me? Well, let's see. But first off, these two triangles have a common angle, right? So this first triangle, NMP, and the smaller triangle, NQP, have the same angle, which is P. So that's one idea. The second idea is that both of them have a right angle, correct? Okay, we have a right angle. Then what can I say about this angle here? So this angle and that angle, what can I say about them?
They're the same.
They're the same because if these two are equal, you automatically get the third one for free. Because if these two are equal to these two, then 180 minus these two is equal to 180 minus the other two, which are the same. And what I'm effectively describing right now is just the final angle. So this is very good. We talked about how the definition of two similar triangles is the scaling of another triangle. So you just take the same triangle, you scale it up, you scale it down. We're not sure yet. So this is very good. All we need to do now is to find the scaling. We need to find the scaling. And let me draw your attention to something. So Ali gave us a really good idea with the famous 3, 4, 5 triangle. We know that PM is 5 unit lengths. Okay. And we're just briefly skimming on the fact that, if two triangles are similar, then they are scalings of each other. So there is some scale. Let's call it scale C. I think.
Scale is not going to be that. It's 4 and 3 and 5 in the scale side should be.
Yes. So by some scaling, so we're fine. No worry. It's just that visually it's not appealing because I drew this as the bigger triangle, whereas it's a smaller one. So that's all. That's why I was a bit concerned. Maybe I'll make it smaller for the sake of niceness. Whatever. So there is some scaling that happens, some scaling factor. Let's make sure we wrote down all of our data. So NP is 4 and NM is 3. So NP is 4 and NM is 3. Okay. Now what do we need to find? We need to find NQ. Let's not forget that. Now my question to you is, are there two sides, one side from the first triangle and another side from the second triangle, that we can compare to see what the scaling was? And what are these two sides?
The M and NP.
Yes, and if you take a look at these two sides, 5 and 4, what would you say the scaling in this case is?
0.8.
0.8, or you could say, 4 over 5. They're the same thing. I don't mean to correct you. You're 100% correct. So this is good. And so if you take this 5, you scale it by 4 over 5, you get 4. Then you should probably take this 4, scale it by 4 over 5, and you should get your answer. Now let's see if we get the same answer. I really hope we do, because otherwise this will be very bad, right? I will be very embarrassed if this wasn't the case. So 4 over 5. So it seems this is a bit embarrassing, right? Because apparently there's something that is inaccurate with the construction. Let me take a moment to look at it. Maybe you can take a look at it with me. Yes, I think I found it. It's because I'll just check something. What happens if I multiply this by 3? Yes, I get the answer. So the reason why this didn't work is because we didn't write our problem nicely enough. So it is a difficult skill to make sure that you can write your data in a way that you can understand and make progress from. So it is not precise to say that this side is sent to this side, because here the angle is red and here the angle is blue. So I want you to think of it like this. So this side is the side that starts from the red angle and goes to the hypotenuse. And if I do the same thing, so I start from the red angle and I go to the hypotenuse. So Pn is a scaling of QP, is what I would like to say. Yes, so that's why Pn is not important. This is why Pn is not important. If you want to find QP, sure, but this is not important. We would like to find NQ, correct? So just start from the blue angle and go to the right angle. So if I start from the blue angle and go to the right angle, I get this side. So the line NM is equal to So the line NM times the scaling, which is 4/5, times the scaling, gives me my intended side, which is NQ. And this is how we conclude. So maybe I'm not that embarrassed anymore. I was able to save the day. That's not too bad. And so if you do this, it's good because NM is just equal to 3. Did I write 4.5? Okay, this is embarrassing again. Please ignore this. 4/5, not 4.5. And then we get NQ is equal to 2.4. 3 times 4/5, believe it or not, is 2.4. So you just need to take care and see which side is being scaled with which side. If you draw your problem in a complicated way like I did, then this is what you get as punishment. So please don't do like me. You can try to do something else. But this is the idea with similar triangles. This is a common theme. I want you to really focus on the fact that you have a right angle triangle and another right angle triangle, and they have a common angle. That's already 2 angles. So you're already thinking of similarities. But at the same time, it's also good to think about different ways to tackle the problem, like the method that was proposed by Flavia. That was also very, very unique in the sense. So that's good. I think that's a good problem. Usually one does not really seek find problems. Usually people have enough on their plates, but when you're a mathematician, it's really weird. So let's deal with more problems now. I think this is right. That's already, I can think about 1 or 2 things we can do to tackle the problem. Let's think about it together. So if RT is equal to TU, then probably this is an isosceles triangle. The sum of the angles is 180. It's 114 plus, let's say, the blue angle. You take the blue angle, first blue angle, and then second blue angle. So this would mean that twice the blue angle would be this. So the blue angle would be 33 degrees. That's good progress. What can we do next? There's a very clever angle that we can try to find now. Which, yeah, sure, if you point at the,
Yeah.
at
The
it,
next part of T.
you can always, so you can read it, so let's say if you want to.
Oh, yeah, but there is no.
Okay,
STR.
STR, yes, so this one?
Yeah.
But why would this be clever?
This clever that we could get.
I mean, it would work, so you would
Third
get,
angle, so the third angle means that opposite angle is equal. So we're gonna make as a normal triangle, which is the opposite angle plus 33. Yeah, we're gonna take the third angle, which is gonna be 92. 83. So the opposite angle also is gonna be 93.
you mean 83?
83, yes.
Yes, because you just applied the 180-degree trick twice.
Yes.
If you apply it twice, you also get, this is 83 degrees, this is 30, so this is 83, this is 33, and then you get x is equal to 180 degrees minus
Minus
23 minus 83, correct? $64 should be the answer, but I would really like to do it in another way. I mean, there are different ways to do it. You're 100% correct on this. But I'm just thinking about something. So we have this triangle, right? And we have two angles. We have 31 degrees, we have 33 degrees.
Mm.
Then we immediately get this angle for free. Right? It's going to be 180 minus 31 minus 33, so 116. Correct? And then you conclude, it's very simple. You just do 180 minus minus 160, which will give you 64. So yes, there are different ways to find the solution. It doesn't have to be one, but I think the most important thing is to be able to find analogies, to be able to find different ways to tackle the problem. I think if you develop your tool set in such a way, you should be very prepared for what's to come. So I think this should be good to conclude for today. Thank you very much for joining. It's an absolute pleasure. And I'll be here if you have questions.
Thank you.